representation of power series. From the geometric series, we have the sum at n go from 0 to infinity of x to the n power can be expressed as 1 over 1 minus x, where the absolute value of x is less than 1. The function f of x equals 1 over 1 minus x can be expressed as an infinite series. However, this must be viewed as f of x equals 1 over 1 minus x equals the limits at n go to infinity of the partial sum s sub n, where s sub n is 1 plus x squared plus dot 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 plus x to the n. The function f is expressed at the limits of the partial sum s sub n. In this case, that is because we cannot add infinitely many terms when we evaluate the functions, but we can take the limit as n go to infinity of the partial sum. Example, write the power series for f of x equals 1 over 1 minus 2x. Observe that this looks like 1 over 1 minus x, where the ratio is now 2x instead of x. So 1 over 1 minus 2x is 1 plus 2x to the 1 power plus 2x squared plus 2x cubed and so on. So this is the series 2x to the n, or 2 to the n times x to the n. This series converges only if the absolute value of 2x, which is the ratio, less than 1. So the absolute value of x is less than 1/2, or negative 1/2 less than x less than 1/2. As you see, the geometric series is used extensively when we rewrite the function in terms of infinite series. For example, f of x equals 1 over 2 plus x squared. It is not of the form 1 over 1 minus x, but if we can rewrite it as a over 1 minus r, then we can express this as the geometric series. The denominator is 1 minus r, so we factor out 2 in the denominator to get 1/2 over 1 plus x squared over 2, but this can be rewritten as 1/2 over 1 minus negative x squared over 2, and we let u be negative x squared over 2, then this is the geometric form. So the series can be rewritten as 1/2 the sum of r raised to the n, but r is u is negative x squared over 2. It is negative 1 to the n, x squared to the n, 2 to the n. And we bring in the 1/2 inside the summation and rewrite it as the sum of negative 1 to the n, x to the 2n, over 2 to the n plus 1. This series converges if the absolute value of negative 1/2 x squared is less than 1, or negative the square root of 2 less than x less than the square root of 2. From these examples regarding the geometric series, we see that the geometric series converges absolutely for the absolute value of x less than r. Then the series a sub n f of x to the n converges absolutely for any continuous function f on the absolute value of f of x less than r. The previous example, f of x is minus x squared over 2.